Hi, good morning everyone. This is Kumar. Welcome to this channel. Today I would like to explain about queue using LinkedList. Previous I discussed queue using. It is also similar to queue using, but its implementation is different way. That is dynamic memory location. That is called a linked list. At present, queue using linked. The major problem with the queue implemented using an array is it will work for only fixed number of data values. It means using array it is a static declaration. Before execution, you can assign some constant, it means the fixed size. It means, for example, queue of, for example, I am using 10. Only the maximum capability in that only 10 values are stored. In case of deleting of the elements, also then you cannot insert extra values. That is the main disadvantage of the using arrays. At present, a queue data structure can be implemented using linked list data structure. The queue which is implemented using linked list can work an unlimited number of values. Is using linked list, unlimited number of values are stored. That is the major advantage for the queue using linked list. In linked list implementation of queue, the last inserted node is always pointed by red, and the first node is always pointed by front. It is also same as using arrays also. That also the rear is representing for the last, front are representing for the in this it is for the front, that is representing for the 1001. It is for the last, that is for the rear, it is representing 101. They are representing for the last node, front are representing for the first. In the above example, the last inserted node is 50. It is pointed by the rear, and first inserted node is 10 and it is pointed by front. The order of elements inserted is 10, 15, 22 and 50. This was the order. The first inserted value, then inserted value, then inserted value. It lastly inserted. The last inserted value is representing for the rear. The first inserted representing for the front. Last is rear. Okay. The operations of the queue using a linked list. Using linked list, the first operation is a must create a node. At the time of creation, it's allocate the memory. That's why the every linked list, the first operation creating for a and adding a nodes and unqueue. It means the unqueue are performing for the inserting of a node. Inserting a node or using unqueue operation. DQ operation, deleting a node. DQ means deleting a node. Displaying nodes. It means the existing queue values or displaying. That is using for the displaying the nodes. Counting. The counting are using for the existing nodes, number of values in the queue. The operation counting the number of nodes for the return. These are the operations. The same way the array using also the same operations. Only for creating and adding nodes or ignore. The remaining can queue, dequeue, displaying and counting also the same. The actual code of the queue. Struct queue is one variable. Sorry, the struct queue here is the name of the structure, into data member and pointer next member, the two members. At the time of creating friend and rare are by default store null values. Now insert a node in queue using linked list. The algorithm unqueue. Unqueue is in a function is ELE is in a argument, the actual stored value, that is the EL, where E is the element to be inserted into queue. Step 1. Allocate memory to the temp, a variable of queue. The temp is in a one variable. This type of, that is the queue type of variable. The temp to allocate the memory. Then step 2. Temp to equal to null. It means in case you cannot allocate the memory, that is only for the temp is representing for null. Otherwise, temp allocate the memory that represent any one memory location. So, in case you cannot allocate the memory, that's why the temp is null. In that case, queue is powerful. So, cannot insert possible. Simply stop. Otherwise, go to start. Now, assign ELE to data field of temp. It means at the time of allocation temp, there are two members, data and another one is next, that is for representing for the address. The first assign temp data, that is the actual passed argument value. Then step assign null to the next field of temp. After the storing for the actual value, then store the temp next equal to null. Then, if front equal to null, it means it is only for the first time. It means the one node in the queue, the front equal to, then set front equal to temp. So the temp is in a front. Then step assign temp to next field of rare. After the creation of the temp, next field of rare, temp to next field of rare to assign. Then set rare equal to temp. Now at present created the temp memory location to assign to the rare. Then print successfully. This was the algorithm of using how it's work. Excellent. Now NQ is the function. At present ELE value 5. For example, now Q temp is in one variable equal to, by default it is assigned to the, then temp equal to Q malloc of size of text. After this statement execution, it's allocate the memory. Create temp only. In the temp, there are two parts. This, for example, 10 to 0. Then temp will equal to null. The temp is representing 10 to 0. Now the condition is fail. So move to else. Now temp data equal to L. At present temp is 10 to 0. The data is representing for this location. So the EL is the 5. So 5 are stored to the temp data. Now temp next equal to null. This was the temp. The next is representing for this location. So null are stored to the this. Now if front equal to null. At present, the front value previously null. So the condition is now front equal to temp. At present, temp is representing 1020. Now this is also front. So if condition is true, else cannot exist. Now where equal to temp. The same way it is also at present where friend and where and temp also representing 10. Now print successfully. This message are displayed. Then simply terminate the function. Again, I can execute and in this case I am executing pass one element 50. Now q equal to q temp equal to null. Again temp variable are created. Now temp equal to malloc. Now after the statement execution, allocate temp in these two parts, in this 2010. Now if temp equal to null, again the condition is false because of at present temp is representing 2010. Now move to L. In this temp data equal to L. Temp data equal to 50. Now temp next equal to null. So again front equal to null. At present the front is representing 1020. Now the condition is fail. So move to else. Rear next equal to temp. This was the rear. Rear. This was the next. Equal to temp. Temp is representing 2010. In this, so store where next equal to temp. Now 2010. Okay, else over. Then where equal to temp. So at present where at present is this for the temp. Now it is not an array. It is for the so it is the first value 1020. Now front next 2010. So this for represent. This way insert number of elements in the AND bias. Okay, clear? How to delete a node in queue using LinkedList. First algorithm. If front equal to null, simply front is representing for null, no values in the queue. So print q is under. So q is under. Simply stop. In case otherwise, else go to step. Now assign front equal to front to a q node temp. It means temp is representing and front is also same value are represented. Now, if front equal to rear, it means only one value in the front and rear returning only one time only. That is only for the only one value in the queue. That time it is if the condition is then set front and rear to null. It means after the DQ perform the one value also deleted the simply front and rear otherwise else go to stuff. Now next field of friend to friend. Assign next field of friend to friend. It means friend next equal to friend. Update the new friend value. Okay. Then data field of temp as deleted. Data field of temp as deleted. Simple. Now free memory to temp. The simply free function to apply, then that memory also free. This is for the good the actual data. Now choose for example two values for 1020. This was friend. This is the value 5 20 10. value in this list it is representing for the friend, it is representing for the player. Okay, now take you. If front equal to null, at present front is representing for 1020. So now condition is fair. So move to else. Q temp equal to front. Now at present front is representing 1020. Now after the statement execution, this for the temp. Temp is representing T. Okay. Now if front equal to rear, the front is 1020, the rear is 3010. Now the condition is fair. So yes, front equal to front next. At present front is representing 1020, front next is 2010. Now this is for the front. After the statement execution, the front is 2010. Then delete the value temp data. At present the temp is representing 102. The temp data is 5. Okay. Now free temp. It means after that statement it is simply free. Now front is representing 2010. Okay. This is for the deleting of the queue using link. The function is link. Now display nodes in the queue using link. The algorithm of display which display all the elements of the queue without modifying the queue is pop. Now if front equal to null, simply the queue is empty. Simply stop one, go to stop. Otherwise go to stop. Print elements in the queue. Now print the element for the existing, assign front to temp. Then assign temp equal to front. Now while temp not equal to null, the temp not equal to null at the means the last node next is representing for null. It means in case you can number of times you can iterate, the last node is representing for the null. That's why the number of iterations, the condition temp not equal to null. Simply print data field of temp. The temp data is print. Then assign the temp next equal to temp. That is the next field of temp to temp. That is in code with the actual code temp equal to temp. Okay. Actual coding. Now choose some example. This for the friend. 1020, the value 5 0 the node 15 0 10 0 10 another node 20 0 10 null. Now display. If front equal to null, so front is representing 20 10 20. Now the condition is fine. So move to else. Temp equal to front. At present front is 1020. Now this for the temp. Print elements in the queue. It is simply display the state elements in the queue. Then temp not equal to null. Temp is representing 1020. Now the condition is true. Now print temp data. The temp is 1020. Data is then temp equal to temp next. Present temp is 1020. The temp next is 2010. Now this was the temp. Now move to while. Again temp not equal to null. Temp is 2010. Again the condition is so print temp data. The temp data is representing 15. Now simply prints the 15. Now then temp equal to temp next. next. At present temp is 2010. Next is 3010. Now this for the temp. Now again move to while. Temp not equal to null. Temp is representing 3010. Again the condition is true. The temp data is representing temp 3010 data, that is then temp equal to temp next. Temp 3010 next is null. Then again move to while. Temp not equal to null. Temp is null. So the condition is fail. So simply print slash, it means the new line. This is for the code for the displaying for the existing nodes. Now counting the number of nodes. That is called the size of the queue. The initial the count to 0. It means count equal to 0. Now if front equal to null, it means no values in the queue. The simply stop the code. Otherwise go to next step. If front to temp, it means temp equal to front. Now while temp not equal to the same condition to apply the display, because it is a slight difference for the displaying, because of display also move first node to last node, count also move first node to, that's why temp not equal to null the condition, and increment count, the extra is for the increment one iteration, it's increase the one value for the count. And then assign next field of temp to temp. That is the temp equal to temp. Then print simply after the completion of the while, the print the count, the queue of size. Now the actual code. This also I am to three values. This is for the file. This is for print 10, 0, 0, 0, 0, 0, another node 10, 0, 0, 0, 0, another node 10, 0, now call the size function. If count equal to 0, the initially count is now front equal to, at present front is 10, 2, for where position, this was front position. Front equal to null. So condition is 5. Now move to else. Q temp. Temp is available. That temp to assign the front. So at present temp and front are returning 102. Now while temp not equal to null. Temp is 1020. The condition is true. So count plus plus. That means the count is initially 0. Now count is 1. Then temp equal to temp. So at present 1020. Temp next is 2010. Now this for the move to the now temp not equal to null. Temp is 2010. Again the condition is, again the count plus plus. Now count 1 at present. Now count is temp equal to temp next. It means temp is 2010. Temp next is 3010. Now at present this for the temp. Again move to y. Temp not equal to null. So 3010. The condition is true. Now count plus plus. Now count value 3. Temp equal to temp next. Temp is 301, 3010. Now temp equal to null. Now again move to while. Temp not equal to null. That temp null. So condition is fail. So cannot execute two state. Now print q, sorry, q size percentage d count. Count value is 3. Now print the size of 3. Q size is 3. Simply